Hello, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at a little review on mole conversions. So right up top we have a little bit of information to remember. Oh yeah, it's worth mentioning that you should write down this stuff on a separate piece of paper. That way you can use it to help you solve some practice problems in class. So right up top we start off with a few conversions that we need to remember. The first one is 1 mole is equal to the mass on the periodic table in grams. The next conversion is 1 mole equals 6.02 times 10 to the 23rd atoms or molecules. Remember guys, these conversions, they're linked together. What they share is moles. Remember, you can always convert from mass to moles, then from moles to molecules, or the other way, molecules to moles, then moles to mass. So remember, these conversions are linked by moles. We'll see how that's important more in the second problem. So remember guys, when we solve mole conversions, we use the method dimensional analysis. So when we're using dimensional analysis, the first thing we always do is we set up our T. Next, in the top left corner, we put what we're going to convert. We are going to convert 2.1 moles of calcium. Next, we need to plug our units in. I always recommend plugging our units in first and then going back and finding our numbers. Moles of calcium need to go on the bottom. The reason why they need to go on the bottom is so then they cancel out. Remember guys, just like variables, like x's, y's, and z's that you use in math, when our units are opposite of each other, they cancel out because anything divided by itself is 1. So that means once our moles cancel, we can put our grams on the top. Now we go back and we plug in our numbers. So we know we're going to use the first conversion because this is the conversion that has moles and grams. Just like in our T, that's where we have moles and grams. So let's start. It tells us 1 mole, so that means we put a 1 next to mole. Next we need to use our periodic table. It says the mass on the periodic table. That's what we put next to grams. So I'm going to pause this for 1 second and go grab my trusty old periodic table. Alright guys, so now I am back and I have my periodic table, so now we can find the mass of calcium. Remember guys, calcium is located right here and it tells us it's 40.078. Remember, I do allow you to round your masses to the nearest whole number. So we can put in 40. Next we solve by multiplying the numerators together and multiplying the denominators together and then dividing. In this case, because the denominator is 1, there's no need to divide it by 1 because dividing by 1 is itself. So then 2.1 times 40 is equal to 84 grams of calcium. Next, we can work on the second problem. So this problem is a little bit more complicated because what you notice, we're converting from grams to molecules. There's no conversion up here to go straight from grams to molecules. We need to go to moles first because these conversions are linked by moles. So we go from grams to moles, then we can go from moles to molecules. So that means we're going to need 2 T's. So we start by setting up our T, or 2 extra parts on our T. Remember what we're putting in the top left corner, that's what we're converting, 30.2 grams of NaCl. Then we go to set up our first section on our T chart. So remember, if we want our grams to cancel, we need to put them on the denominator, so they're opposite of each other and cancel out to 1. Next, we need to go to moles. Remember, we determined that these are linked by moles. We need to go to moles first before we can go to molecules. So we put moles of NaCl on the top. Our grams cancel, and now that we're in moles, we can convert from moles to molecules. So again, we put the moles on the molecules so the units cancel out to 1. And then on top, we can put what we're converting to, molecules of NaCl. So now our moles cancel, and we're left with molecules. Now, we need to go through and plug our numbers in. So this section right here, this first part that's blank with numbers, we need to figure out which conversion to use. We use the first conversion because it tells us moles and grams. We have moles and grams. So it tells us 1 mole, so we put a 1 next to mole. Then we go back to our periodic table because this is the mass on the periodic table. That's what we put next to grams. So when we're dealing with NaCl, we have to remember to find the total mass of sodium and chlorine. So we can come over here, we look at sodium. Sodium has a mass of 22.990, which rounds to 23. So we can calculate the grams of NaCl on the side. over here. Well, I'll do it where we can see it. So we'll do it on the bottom. Grams of NaCl. That is going to equal, we just said 23, plus, we look up the mass of chlorine, 35, and that equals 58. So we can plug in 58 for the grams. Next, we're going to use the second conversion, because in this one we have molecules and moles. That conversion has moles and molecules. So again, this is 1 mole, so we put a 1 next to mole. 6.02 times 10 to the 23rd molecules are atoms, and that's what we put next to molecules. Remember guys, anytime you are typing into your calculator, anytime you're typing in scientific notation, make sure you give it its own parentheses. Include the exponent on the inside of those parentheses. When you solve this and type it in your calculator, you find that the answer is 3.13 times 10 to the 23rd molecules of NaCl. That's the answer. Like always, guys, if you have any questions, please write them down and let me know when you bring them to class. Use this to help you complete the mole practice problems. I hope everyone has a good day. Bye.